Okay, well, what you're looking at is the last lecture uploading. Typically it takes about 10 minutes to save these lectures, and then from where I am, it takes about as much time recording the lecture as to upload the lecture. Actually, I'm pretty happy with that, given that I'm uploading these from Mexico. I had no idea what kind of network access to expect from my hotel, but it's not that bad. It's actually pretty good for what I thought it would be. So, needless to say, I'm sharing this connection with a lot of other people in the hotel, and I don't know. Anyway, I didn't mean to bring that screen up, but it did come up. So, okay, let's go back and finish up our program now. We're going to go to monthly item. Let me go into projects view here. We're going to go into monthly runner rather. And we know that we have not actually implemented this process method in any of our classes, but it's actually quite straightforward. Let's start with life insurance. Here's the process method. We're getting in a string called data. It's just a string. We don't know it came from a file at this point. And life insurance does not know where it came from. It just knows it has a string. And what's that string going to look like? It's going to look like this. 4 pieces of data separated by a space. If you remember from Computer Programming 1, that's very easy to separate. All we have to do is this. I'm going to say data dot split, and then pass a delimiter, which in this case is going to be a space. Space is a terrible choice for a delimiter, by the way. Probably I should have used some other character, but okay, don't worry about it. Now, what that's going to do is that's going to return to us the data in pieces, broken apart at the split, and it's going to return that to us in an array. So string all data equals data.split. Now what we can do is we can say, let's remember what a life insurance looks like again. It's going to be first name, last name, payment amount, insurance type. Okay? So, first name, remember we have that declared in the superclass. First name equals all data, and then we start counting at 0, so the 0 element. Last name equals all data, and then the 1 element, which is our next element. Okay. Oops, need a capital D on there. Okay. Let's see. And then bill amount, we're going to have to convert from a string to double here. So double dot parse double, all data, and then the 2 element, which is actually the third, and finally policy type equals all data 3. And then we'll just do a system out print line. Okay, and we'll say processing life insurance for first name plus single space plus last name, and this, I know this is going to fall outside, in the amount of, I'll move this over so we can see it, in the amount of plus bill amount. So this will represent printing out a bill to send to the customer. That's what we're representing here. Here we see, though, it's honestly quite straightforward. Notice that all of the logic that knows how to parse a life insurance file is where? In the life insurance class. Let's take a look at annuity. That's going to be very similar. Okay, take that out. And we're going to go to files, an annuity, first name, last name, payment amount. This one's really simple. Okay, annuity. So we'll say string, square brackets to indicate an array, all data equals data dot split. Okay, split based on the space, and there we go. First name equals all data 0. Second name. Last name equals all data 1. And finally, payment amount equals double dot parse double. Okay, all data 2. And there we go. And then we simply do a system out print line, processing annuity for plus first name plus space plus last name plus in the amount of plus payment amount. There we go. And again, this would represent sending the customer a check. In reality, we could do like a web service interface call or some kind of call to another program that would actually send out that check. Okay, again, I ask you, where is all of the logic that knows how to process an annuity? It's in the annuity class, and that's the whole idea. Okay? Employee, probably the hardest of all because we have so much information in an employee. Okay? Okay, let's take a look. So, string, square brackets, all data equals data dot split, split based on the space. Okay, yikes. First name equals all data, 0. Last name equals all data, 1. Let's see, okay. Payroll amount equals double, dot parse, double, all data, 2. Bank name, what don't you like? Oh, I misspelled it, okay. Bank name equals all data, 3. Routing, transit, those are those first 9 numbers at the bottom of your check, if you have a checkbook. Not many of those going around anymore, are there? All data, 4. Oh, come on. Okay. Account number equals all data, and 5. And there we have it. And now we'll say system out print line. We really shouldn't do a system out print line from here, but we're just trying to simulate something. So normally, though, we would not do a system out print line from a data class like this. I just realized I'm kind of doing something bad. But we're just simulating an event. So we'll take it at face value that that's what we're doing. Processing payroll for first name plus space plus last name plus in the amount of plus payroll amount. Another thing we certainly wouldn't do is put somebody's payroll amount in standard output. Okay, there we go. Let's go back and run our file again, and this time let's run it through the debugger and see what happens. So I go to monthly runner. We're going to run through the exact same files that we did last time, but we're going to watch what happens when we process them. I go to monthly runner and I choose debug. The Pepto-Bismol line turns green. I choose F8. We get our list of files. We've already seen this in the variables, so I won't, well, maybe I will try and show. Let's see how much I can show. I'm trying, it's hard to get everything to fit on this one screen, so I'll see how much I can show. Looks like that's going to show a lot. Okay, okay, F8. Process our first file. Okay, our first file is annuity 01234. File type is annuity. Okay, so F8, F8. Now, question for you. I'm going to choose F7 now. Where is it going to go? Notice what MI is. MI is monthly item. MI is data type monthly item. Where is it? Where's the debugger going to go when I choose F7? What method? Well, MI is the interface type monthly item. Remember, the object that's actually stored in there is annuity. When I choose F7, look where we are. We just stepped into annuity. It's going to process this annuity, print our line, and then we go back and we go for the next file. Next file, okay, once again, the next file is also an annuity, this time for Kaz Dolowitz. Okay, so once again, F7, going to take us into the annuity class, process, and we move to the next file. The next file is also an annuity, and let's see what it is. It's an annuity for Oscar Goodman in the amount of $8,500. We pass the data to the process method, and there we go. Now, after we've done that, the next file is going to be an employee. Let's go to create monthly item. Let's slow down and look at this. File type is an employee because it's employee 01237, where 01237 might be something like an employee number. Let me F7 into our factory. Is it an employee? Yes. Create and return an employee. Okay, and there we go. Let's go into the process method. And look now, we're not an annuity now, we're an employee. Okay, hopefully I got this one all right. I didn't double check myself. So we go through, assign the first name, last name, payroll amount, bank name, routing and transit, account number, print it out, and there we go. Now we're back to monthly runner. Okay, next file is also an employee. I go to process. Once again, we're processing this employee. Okay, and if we look in the debugger at the variables, we can see this employee is Sami Farha. Okay. Okay, and F8, 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 we go back. The last one we have is a life insurance. Okay, so let's take a look at this. Life insurance 01236, file type life insurance. Let's step into create monthly item. We see it's going to create and return a life insurance object. Okay, and now we're going to go into the process method. And look where we are. Are we in annuity? No. Are we in employee? No. We're in life insurance. Okay, so we parse out the life insurance information, print out our informational line, go back, and now we're finished processing files. Okay, so I'll click on output, and I'll show you what's been happening this whole time, if I can get it to come up here. Processing annuity for Phil Smith, processing annuity for Cass Dolowitz, processing annuity for Oscar Goodman, processing payroll for Mary Filipowitz, processing payroll for Sami Farha, and finally, processing life insurance for Bugsy Siegel. Now look at what we just did. Look at what we just did. Do we know what's going to happen on this line? In monthly runner, do we know what's going to happen on this line? No, we don't. We don't. We leave that up to the object because we know the object implements monthly items, so it has to have a process method. That is the definition of the command pattern. The definition of the command pattern is having one class that's causing something to happen by using either a subclass or an implemented interface without knowing what that subclass or implemented interface will do. That's the definition of the command pattern. Okay? It's also a great show of polymorphism because the process method is defined on this type monthly item. The method signature is defined, but what it will do depends on what kind of file we have, annuity, life insurance, or employee. And that behavior is not defined in the interface because it can't be defined in the interface. Instead, it's defined at the level of the class that implements that interface. Take a moment and think about that. Take a moment and look at what we have here and think about what is happening. Let me move over so we can see line numbers. Think about what's happening on line number 54. Okay. So how do we do? Our goal was to write a program that would be able to process these files without an if test. And how do we do? Do you see any if tests here? I don't see any if tests here. Of course, if you've been paying attention, you know, actually, I do have an if test down in the factory. Well, shoot. Yeah, an if test usually shows that logic is in the wrong place. But you know what's nice is that we do have a string here, and we're creating a class with an identical name. Anytime you see that, anytime you see an if test that's doing something like this, where you see the context of the if test repeated in the body of the if test, think to yourself, reflection. Reflection is a very powerful thing in Java. Reflection is a very powerful thing. Think about this. What if I could create an object of a class based purely on a string that represented the package and the class name where that class is located? The package here is batch processor. So let's say if I said batch, end quotes, batch processor, which is the package name and then a period, plus file type. What's that look like? Okay, so string full class name equals batch processor plus file type. What if given that I could create a class? Of course, you probably figured out where I'm going, and that is, yes, this is possible. What I'm about to type is a lot of confusing stuff. Don't worry about the details. Sometimes we can't worry about details, and we just have to pay attention to the bigger picture. And this is one of those times. Don't worry about every method I'm about to call. Just know what I am doing is called reflection. And what that will do is take a package name and a class name, look for that, and try and create an object out of it. Okay, here's what it looks like. Class dot for name full class name dot new instance. Okay. Okay, we have some exceptions to handle. I'm just going to rethrow those. Throws exception. The exceptions would be, what if this class name doesn't exist? It's a very legitimate question. What if it doesn't exist? Okay. Class.forName.newInstance, we're going to cast this to a monthly item, and we're going to return it. And with that, we can remove everything here. Okay. So what we're doing, class.forName.newInstance will take a string, look for a class that matches that string, and create an object out of it. And we're simply returning that. If you wish to see this in more lines, we could do it like this. Monthly item mi equals, like so, and then return mi. Okay? Use reflection to create an object based on a string representation of a class name. Okay, there we go. That's it. Now, no more if tests. I'm going to delete this, as a matter of fact. There are no if tests anywhere in this program. The only trick is we need to figure out how to deal with this exception, okay? And this is where we like our try-catch block, because this exception could happen. What if somebody stuck another file in there that doesn't belong? Remember that one file we ignored, mutual fund? What if we put that in there? One moment while I find it. There we go. So what if I copy and paste in the mutual fund? Okay, we're going to try and create a class called mutual fund now, and no such class exists. What do? Do we want to kill the program? Probably not, because we can continue to process everything else. What we probably want to do is just move on to the next file, maybe log this information, maybe even send out an automatic email about it. So I'm going to add another catch block, exception E. Okay, and we're simply going to say, do we have any logging built in? Oh, damn. Okay, we don't have logging built in, so I'll just do a system out print line, unknown file type found, message plus e.getMessage. Now, once again, let's pay very close attention. Oh, you know what? I'm sorry, I need to make that the last catch. 1 second. Okay, has to be the last. The more general always has to be last. Okay. Now, think very carefully here. The exception's getting thrown here. Where do we want to catch it? If we don't have a class to process it, is there any use in doing this? Absolutely none at all. And remember the way an exception works. It gets thrown at a certain point, and all lines are skipped until it is caught. So we want to put the catch for this exception after mi.process, because if we could not create an object of this class, an exception will be thrown. And if we could not create an create an object of this class, nothing will be in mi. And if we try to invoke a method on a variable that does not have an object inside, we'll just get another exception called null pointer exception, and that could kill our program. So the best thing to do here, if the exception is thrown here, is to skip everything down to the catch block, but keep the catch block within the for loop. That way, after the exception is caught, it's going to move to the next line, which is simply going to repeat the loop with the next file. So let's debug again, and let's watch this carefully. Okay, my old debugger's still going, so I'm going to terminate that, right-click, and debug. Okay, so F8, 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 F8. We know it's going to be the same order as before. The first one's going to be annuity. Process our annuity. Okay, next one, let me slow down and look inside of our factory method. Boom. What's our fully qualified class name? Let me move this up so we can see it. Batch processor, which is the package name, dot annuity. Okay, so we're telling reflection to create an object of this, and what type do we get in the MI variable? You guessed it, we got annuity. We got an annuity object in the MI variable. So we F8, F8, and what happens when we go to process? We're an annuity, because that's an annuity file. Okay, go back and go again. File type again is annuity. We'll walk through this one. Okay, what's our next file name? Employee. So let's go to the factory method. Okay, what's this going to create? Batch processor.employee. See that down here? So what's it going to create? An employee object, and it's returning an employee object from the factory method, from the factory design pattern. Okay, read the data, and here we are, an employee. Okay, next one's employee. Next one's going to be life insurance, more than likely. Yep, there's our life insurance. That'll process properly. And the last one's going to be that mutual fund. And what we're going to see here, I'll slow this one down. We go into the factory. Okay, it's not going to be able to find this class, so it's going to throw an exception. And notice where the exception goes. It goes to this catch block, and it skipped all the processing, because if we don't have a class to process, then there's no use in doing the processing. And there we go. Once again, program runs well. So notice at this point in monthly runner, there is absolutely no hard reference to annuity, customer, or life insurance. I can Control F. Let me bring this up so you can see it. Type in nothing. Annuity, nothing. I can type in employee, nothing. Can't find it. No reference to those classes, yet those classes are still being called to do processing. Once again, this is the beauty of the command pattern. And if you're with me now, you're in good shape. If you're totally lost, the next few courses you take might be a bit of a struggle, because this is the foundation of object-oriented programming. Okay? So what's the point? Am I just trying to show something cool? Well, there is a point here. This program we're looking at is very similar to one that I actually wrote. Remember I told you those two quotes from ucjava.com from the instructor I talked about, the instructor from Sun? Let me see if I can go back there. Okay. Well, now the connection's slow. But remember, I said if you're not using interfaces, you're only using half of Java's potential. You can judge how well an object-oriented program is written by how few if tests it has. I asked you, are we using interfaces? Let me pull up my, shoot, where'd it go? There we go. Are we using interfaces? Yes. Are we using if tests? Not one, nowhere. We're not using an if test anywhere, okay? So I told you that I took this training, and that sank in my head for about 9 months, till I finally figured out what he meant by it. And at that point, I was put in charge of writing a program that would process chargebacks from Visa. So when you have your credit card and you see a charge that you dispute, you typically call the bank that issued your card. And that starts off a long process. Step one is that bank takes your complaint, goes to Visa. That bank is called the issuing bank, the bank that issued the credit card. Step two is that Visa takes that information and sends it to the acquiring bank, or the bank that actually did the transaction for the merchant. The bank then sends that data to the merchant responds. It goes back and forth about 9 steps. The bank I worked for both did issuing of credit cards and also processing of transactions. And what Visa told me is they needed me to process files that began with a number 0 through 9. And so I wrote a program very much like the one we just saw that processed files 0 through 9. Now, for every day, the program, we had a big rollout, and I remember it very, very well. The rollout was September 16th, 2001. For every day it was late, it cost the bank $500,000 because it's like hot potato. If you have a chargeback, whoever's hands it is in, when it expires, is liable for the money. Okay, so the way the bank worked, every day this program was late was $500,000. So I always say that you should always plan in some buffer. You should never wait till the last minute. Unexpected events happen to everybody. And we had very little time for this program, very little time at all. And it was started in it was planned in late spring of 2001, which was not a good time in Cincinnati. If you remember, that was around the riots. And it was scheduled to be finished September 16th, 2001. Well, if you remember anything about that week, there was a fairly major event that basically disrupted business for a good few days. You know, you never know this stuff coming in front, but the project didn't have enough time, and then right towards the end of it was September 11th. So, in any case, I remember very well putting this into production, and then I was downtown, and I turned it on September 16th, and I was worried. I went out, walked around, and what would happen is it would process these files and then delete them. So I went outside, walked around a few times, went back up to my office, and to my amazement, it worked like a charm. I was absolutely blown away. The program that I was replacing was 9,000 lines, 9,000 lines of logic. Out of those 9,000 lines, there were about 3 methods. Out of those 9,000 lines, there were a total of 9 comments. I was charged with taking this 9,000 line program and doubling its functionality, and there was no documentation. One of those lines that was commented was this: status.update X. Out of those 9 comments, this was one of them: update the status to X. And so that's what I had to work with. So there were 8 more comments left in the program. Very little documentation. The person who wrote it quit. So anyway, I set it to go live, turned it on, went outside, walked around the block a few times, went back upstairs, and the thing worked. What's even more surprising, while the program I was replacing was written in Java and was 9,000 lines, the program that I wrote to replace it did twice as much functionality and was 2,000 lines. Of those 2,000 lines, about 1,000 were comments. So you see, when you write efficiently, when you take out if tests, when you make a lot of small classes instead of one big class, you end up with a smaller program. The program that I replaced was 1 or 2 classes. The one that I wrote was, I think, about 36 classes. But they were smaller classes, and the logic was in the right place. Okay? Where's the logic to process an employee? It's all an employee. Life insurance, annuity, annuity. The logic to run through files is in monthly runner. So this gives us a more understandable, more compact program. But what does that buy us? Well, when this went live, about 2 days later, I got a call from Visa, and they said, oh, shoot, you know what? We forgot to tell you there's actually a 10th step that you need to process. And so you need to process this other file. How long do you think it's going to take for your program to do that? Inside, I knew I had written the program how I'd written it, and adding another file was very easy. It would probably take me under a day. So of course I told Visa, I don't know, that's a big change. It's probably going to take 2 to 3 weeks. Then what I did, watch this. I'm not going to touch any of these classes here. We're going to say that new file is mutual fund. Notice that it is comma separated. So full name, okay, ticker symbol, and then last close price, and then change for the year. So new type of data. Now I'm going to go back to projects. I am not going to touch any of the classes that I've already created. I'm going to right click on batch processor and say new Java class, and we're going to call this what? Remember what that file name was? Mutual fund. Okay, remember, I'm not touching any other class right now. Finish. Mutual fund extends customer implements monthly item. Okay, control save. Okay, click on the light bulb, implement all abstract methods. Okay, let's see. So we have a few new attributes we need. String ticker symbol, double last close, double percent change. Okay, and right click, refactor, encapsulate fields. I'm still not touching any of the other classes. Refactor. Now process. Okay, string all data equals data dot split. Now, let's say that this is a new company we acquired that handles data in a different manner. Instead of splitting based on space, it splits on semicolon. So we provide a semicolon. And now we have string string full name equals all data 0. We're going to need to break that one down. String all full name equals full name dot split. We'll split this one based on the space. And now we can say first name equals all full name. I need to change my capitalization there. 0. Last name equals all full name. Did it again. 1. Okay, now ticker. Let's see. Let me look at my mutual fund. It was full name, which we split into first and last. Ticker, last close, percent change. Okay, ticker equals all data 1. Okay, last close equals double dot parse double all data 2, and percent change equals double dot parse double all data 3. And there we go. So we've now pulled apart all pieces of data from our mutual fund, and all of that logic exists in the class name mutual fund. Now what I'm going to do is a system out print line, oh come on, and say processed mutual fund for, and we'll go ahead and say full name, ticker, okay, and save. Now, I didn't touch any other class, did I? Let's go back to monthly runner and run this program again. Okay, debug file. I'll run through the 3 annuities, the 2 employees, and the life insurance kind of quickly because we've already seen those. F8, F8. Okay, this is our first annuity, second annuity, third annuity, first employee, second employee, life insurance. And now our mutual fund. Okay, let's take a look. Mutual fund, create monthly item. Let's F7 into this. Now we have the mutual fund class. We create and return it. Okay, read in the data. Okay, and now we call process, and watch where we go when we call process. What class are we in? We're in the class mutual fund. Remember this guy? We just made him. F8, 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 F8. Uh-oh. Looks like I made it mad there. My parse might not be working right in mutual fund. Let me see. Okay, all data 1, 2, 3. Let's see. So I split last name, first name, all data 0, 1, 2, 3, and double. It might not like the minus there. Maybe I should, okay, because that's 1, 2, 3. I'll run that again. I think it doesn't like the minus, so we'll try that again. Okay. But what I'll do is I'll put the breakpoint right in mutual funds so we can skip all the other stuff. Okay, so let me go back, monthly runner, and debug again. Okay, let's see. And again, I'm going to fast forward through this first part. As a matter of fact, I'm going to hit play. Okay. Um, sorry, let me hit debug and continue, which is F5. That's going to take me down to mutual fund. Now, all data.split, let me look at this a little bit closer. I choose F8, okay, and then I'm going to go to the debugger console. Let's look at variables actually, and let's see what we have in all data. Oh, you know what? Oh, that's the problem. I used the wrong delimiter. It's a comma. Okay, it's a comma, not a semicolon. Okay, that was an ID10T error. So let me change that to a comma. Yeah, simple error, but no problem. We'll fix it. Now let's debug again. So yeah, simple oversight, no problem. Okay, debug. Okay, F5 through this part. Let's just go right to the mutual fund. What we see here, all data, comma separated. Okay, if we look at all data, we see now 4 different pieces of information: the full name, Bugsy Siegel, the ticker symbol, the last close, and the percent change. Okay, so let's take the full name and split it up into first and last. There we go. Let's get the ticker symbol, the last close, and the percent change for this year. And finally, let's output it. That's going to take us back to monthly runner, and we're finished. Look at output, processing annuity, payroll, life insurance, mutual fund. So the time that Visa told me they forgot to tell me about a file format, I left the program running. I made a class called Process 10 because that was my naming convention. I named the class Process and then whatever file number it was processing. So I called the class Process 10, compiled it, and I threw it right out in the directory where the program was running without even stopping the program. And the program started processing those type 10 files. I called Visa back about 2 hours later and said, no problem, it's all taken care of. So that's the benefit of good object-oriented design. In that new program I wrote, my goal was to see how many if tests I could eliminate. I ended up writing the program and leaving about 1 if test. Several months later, I left that bank, quit, moved on, and someone else took over that program, and I'm sure it's nothing like what it used to look like. But that's the lessons of good design. So we use the Java Bean standard with encapsulation. We separate out our business logic and our user interface. We separate our data and our user interface. We use design patterns. We try to avoid casting. That's a sign that logic is in the wrong place. We try to avoid if tests. Remember the stages of learning design patterns: acceptance, recognition, internalization. Remember the categories of design patterns: creational, structural, and behavioral. The factory pattern we used is creational. The command pattern is behavioral. We didn't get to a structural one. Remember polymorphism and how polymorphism and the command pattern work hand in hand. How we're able to invoke a method on an interface without knowing what's actually going to happen. And the truth is that behavior might not have been implemented yet. Okay? Remember that we cannot create an object of an interface type. Interfaces cannot have constructors. All of these are excellent quiz question suggestions. That being said, we're at the 40-minute mark, so I'm going to go ahead and save this off and upload this. Put questions for this on quiz question suggestions for quiz number 4. Thank you.